My name's Ruben Miller. I'm principal consultant for the PS Group Software AG. Been working there for about 2 years now, a bit over 2 years. But I've been working with Comvelocity for the last 5 years, 5 or 6 years. And so I'm a power user from Comvelocity, so develop microservices, just generally explore data inside the platform, debug really weird behavior from agents and microservices. And so I saw the need to able to have a really flexible tool that I can get to my data quickly and give a bit of like a overview of the whole fleet data within Comvelocity to just help me with my day-to-day tasks. So I developed a CLI application, which is a standalone binary written in Go. And I'd like to kind of showcase it today. I don't want to repeat myself too much because I have already done this presentation 3 times, and I can make that other more kind of introductory course available via video. So I want to really spark the desire to use the tool. So I want to show my real use cases. And those will be, one will be simulating a real agent or a agent-like behavior just by using CLI commands. So we can generate measurements, work on operations, and then I also want to look at integrating it into a CI/CD process. So how do we do a more GitOps style deployment for new artifacts? For example, a software or a microservice or a hosted application or whatever. So I won't cover too much why Postman doesn't work. It just doesn't scale for day-to-day usage and quick. But I guess a lot of people already know that. So the Comvelocity Go CLI comes with one standalone binary. It's called C8Y. So it has a whole heap of commands, and in the end, all of these commands basically map down to different API requests. So for example, here we have like if I just want to create an alarm, you start always, because it is a hierarchical kind of command line setup. So you always start with C8Y saying I'm Comvelocity. What artifact do you want to work with or entity in Comvelocity? So in this case, alarms, or if you wanted to do events or applications, tenant options, you name it, there's one there. And what I want to do with these alarms, I want to create something. So it's kind of like hierarchy Comvelocity, inside Comvelocity, you want to do alarms and then create. So all of the commands follow this structure. And there's a lot of commands, so you needed this nested. Otherwise, you'd have about 150 commands. And in the end, so each of them have like arguments that build in the end this REST request that can be sent out. At a very, very basic overview, that is what it does. However, there's a few kind of core fundamentals that I bring along there with inspiration from PowerShell. But don't get me wrong, before earlier version 1 was only available in PowerShell, this has now version 2 has nothing to do with PowerShell. You can run it from PowerShell if you want, but it's not dependent on PowerShell. So I mainly run it in Zshell, or like a Linux kind of environment that you can do nicely in WSL if you have that installed on your computer, or if you're running on Mac OS, it has a terminal built in. So what I want to run, and that's the last of the PowerPoint, so don't worry. Now I want to run through the first example, and it will then flow into the second one. So the first example, I just wanted to, first of all, a classic thing when you maybe have a trial tenant and you're going, okay, what is Comvelocity? How can I get a feel for it? Or maybe I'm trying to communicate to some of the people in the department, how does a device look in Comvelocity? So usually start with, how do I create dummy devices? So you can show something in the UI. Otherwise, the UI is very blank, because if you have no devices, there's no pretty much data to show. So I have previously run this. So I'm just going to clean up my devices first. Okay. Now, for when I'm in a terminal, I need to activate a session. So a session includes all of my connectivity parameters. For example, what Comvelocity host am I talking to? What's my username? What's my password and everything? So for this session, I've set up a profile. And this profile is actually encrypted. So I'll enter my password because I don't want to show people my password here. And it's loaded my profile now. I can see what I've loaded by just doing session. These are just a few kind of shortcuts so I can show where am I, because you can change your context quite easily. So, okay, I'm on this tenant, all good. So we can see here on the UI, this is the tenant I'm in. So I'm just going to run the cleanup devices again, just to make sure. And I think I've deleted something there. So we'll get started. So I want to first, let's create, let's say, let's create some devices. Sorry, I think. So I've just used it to create 100 devices. But I saw I already had devices in there, so I'm a little bit suspicious I've done something wrong. So I'm just going to delete them. I mean, why not? Delete. So this is a typical way that one command on its own isn't very powerful. I mean, you might as well use Postman if you're doing that. But where this comes in is I want to then chain different commands together. So I want to get the list of devices. I want to use a page size of 1000. That's just the short form. You could also do page size 1000. Oops, sorry. Devices. Page size 1000. Then what do I want to do with this? So each device result that comes out, I want to then delete it. So I'll go again, delete. And it's what's happening is my my command is pipe aware. So it reads basically from standard input and then creates an internal for loop and then iterates over the requests. And then for each input that it receives in the standard input, it then generates an API request. So for example, the delete does then a delete. So a REST API delete command to this one. And because delete commands don't have any content, it just shows you out here. So you get some kind of visual feedback. Okay, so if we go back here and if I go reload, everything's been deleted. Obviously, you don't run that in production. However, there's some safeguards in place, and this is probably the number one thing when you probably set up your session that you go, how do I delete something? It's saying I need to activate a mode. That's for good reason, for exactly to prevent you accidentally deleting everything, because that's definitely something you don't want to do. I'll go back to my setup and let's recreate those 100 devices. So it's also shown the default kind of view or the default output that it spits out into the console is table format. So this is just a representation of the JSON data. Because the JSON data, as you all probably know, there's a lot of different properties on it, and only about 5 of them are interesting, especially in this case. So you can actually control what data you view on the console by your own selected views. So for instance, in this kind of setup, I actually have a special fragment called deployment group. So I'll be using that in my CI/CD process later, where I have a canary kind of setup, so I can mark special devices as being special ones that I want to treat for like beta versions of the new software, and test that everything works fine there before rolling out to the real one. So all of this you can actually customize yourself. It's not baked into the binary. It's all controlled by a view. So if I just look at my device custom view, there's like a JSON file here where I say, what different columns do I want to actually show in my table? It's a purely UI, like a usability view. If you don't want it, fine. You can actually change the output. So if I go to devices, list, output, you have here different options available. So you can do CSV without headers, CSV header with headers, JSON, server response, and table. So the default is table when it detects that your output is a terminal. So for example, if I want JSON, it'll give me a subset still with the view applied, because I don't want to see everything. If you want to see the raw thing where it has, the asset parents and all of that kind of additional stuff, you can still get all of that available. So it's quite flexible, but I really would encourage the table view. Makes it nice and condensed, so you can really focus on the information that's important to you. And it's flexible enough that you can customize also these views per session. So if you have a specific customer that always uses, I know that with a customer underscore a fragment kind of notation, you can kind of define that for that session. And then when you're switching between customers, you have your own kind of what's interesting for them. So you can create this globally or per session. It's kind of up to you. And all of how to do this is all documented, so I won't spend too much time on it. But that's there. Okay, so now we have the test devices. Now I want to do something with them. I mean, because just doing that alone is not very nice. So I'm going to do the start measurements. This is just generating, so we can see here what it's actually doing. So I just prepared some shell functions that I can just quickly do this, but I normally just type them alone. So here we have chained multiple commands together. So the very first thing is because I want an infinite loop. So I have a list of devices, my 100 devices. Now I want to create a measurement and one event for each of these 100 devices. So you can actually chain them all together really nicely. Is that if you have like an infinite loop, which basically just say, hey, let's repeat the contents of a file, where inside that file, you can actually see here, all it is an ID and name to the device. Because Cumulocity, the CLI is pipe aware, it's actually quite smart and go, oh, okay, I can see you're inputting JSON ID. I need that because I need that to when creating the measurements. So it kind of feeds that in and the for loop and then iterates over the different lines in the file. So here I'm creating a measurement. I'm creating the measurement using a template because I mean, static templates, if it's just a static JSON, that's also not very helpful. I want to make this kind of data look alive. So I support a templating format called JSONNet, which is basically a superset of JSON. So if you know JSON, you can write a valid JSONNet file or JSONnet, I think it's called. So you can write a valid template file. Inside that template file, you can also do like variables and randomization has like a standard library that you can call, formatting functions and whatever. You can do quite a lot with it. Again, that's quite documented well on the JSONnet website. You can go do all the tricky stuff. Then in addition, so the template is basically a global. I think it's supported on pretty much every command that produces something. So for GET requests, there's no body to really template, so it doesn't have it. But all for like updates, posts, and whatever, there's always or like a puts and posts API calls. It supports template. Another global flag that I also support are workers, delay, select, and there's about 30 others. So workers is you can actually configure that this instance can spawn up to 5 sub kind of routines that also then process these incoming requests to create a measurement. So you can kind of scale it a little bit better because you can imagine if I have 100 devices, if I kind of want to give a feel that all of the devices are a little bit independent, then it makes sense to increase my number of workers so you can distribute the incoming requests a little bit more evenly. Otherwise, you'd be having a very, very slow for loop that would do it everything, create the measurements serially. But also, when you can imagine a for loop, it doesn't make much sense to do that as quick as possible. I mean, you can if you want. However, I mean, what data comes as quick as possible? So, you're not talking we're setting data every 20 milliseconds or something. And there's usually some kind of longer time interval, 10 seconds or whatever. So I'm using all the commands for the delay. And all that does say, after you've submitted your request, just wait 10 seconds before getting the next job. So each of the workers operate independently and they respect this delay. So you then can basically select the polling interval. And you can kind of see here that it comes in dribs and drabs. This is because that 10-second delay which is coming through. Then we're doing a little bit more fancy stuff because I figured, why not? So there's a few kind of generic utilities that I also write. So I have another one that can repeat the input, but can you please not repeat sometimes? So it has a random skip. So this means that from the output of the measurement, the actual measurement body will get passed down the pipeline because it's afterwards. So I'm chaining here. It then only passes on to the create event, I think 70% of the time, or I can't remember what way I did it around. I think one will mean it will always skip. So I think 70% of the time it will skip. So it'll only randomly create an event 70% of it, 30% of the time. So how does this look in Cumulosity? So that's probably a bit more technical point of view, but just to have a look there. So we just pick a random device, have a look here, and the data is, oops, okay, but on real time, and then just do last minute. And you can see data is kind of coming in at 10-second intervals. And so you can actually control this quite nicely and do whatever kind of um, input data that you want, or if you want to create an event. So hopefully, and you see here, it's also created events. So you can kind of give the feel that you're really having an agent in the background, which is great. Also, if you're just, I know, demoing to new customers saying, can you show me what it does? And maybe they want some really customer specific data. So you can just inject that into your template. And then you already have data that looks like the customer's real data in a prototype in 5 minutes. So you don't need to write any complex, do an agent and how does that connect and all of that stuff. You can really, it's a 4-liner and then you're done, which is kind of cool. Now, what's even better, because this whole concept that the Cumulosity inputs or can read from standard input. So basically what you pipe to it. You can actually pipe anything to it. So, I mean, in this example here, I was just iterating over my list of files that I created, like list of devices that I created before and stored it in a file. But let's say if you have like I don't know, a Python waveform generator that can do some really cool SciPy, that has some, really cool signal generators that can do some sinusoidal patterns and do whatever. You can also do that there and then pipe it to this creation. So I created one which is just a really, really basic waveform generator. So if I do this I'm only doing this for device 1. And now if we go back to device 1, it's going to come in a minute. So you can set up your own kind of waveform however you want. Now, my tool doesn't need to know because I won't be able to meet all of your needs. So by being able to accept just random standard input, you can it works really well with other third-party tools. So Python, where you're a bit more maybe familiar with doing complex kind of signal generation, you can do that. I think there's just here's a little bit cleaner. Last minute. You probably have to load it again. Yeah, so you can have like a really nice kind of setup there to display the data in however you want. Maybe that will render a little bit better. Yeah, just the limits were changing. Yeah, so it's some kind of random cosine sine combination with different amplitudes and whatever. And all that required was one short thing. If I get it here. So these three NumPy things in Python, I iterate over that forever while true, and I just dump some JSON on the output. And that's it. And then it pipes down and it continues nicely into my application. So it makes it very easy to create very complex kind of signal generators so it looks a little bit like real customer data, which is also great for like doing mockups if you're working on a UI and you need something kind of a bit more real. And you can set it up in minutes. Exactly. Okay, so then, so we're still on the how do I simulate a device and this kind of stuff. So that's okay with the measurements, but what about operation handling? Because that's a fairly common use case. So how about simulating processing of an operation? Again, that's quite easy. So I've prepared something. So since current customer of mine, we're doing a lot of device management. So it's a little bit device management orientated, but you can apply this to any operation. It's just as an example. So I'm just going to start my software real-time listener because currently I do only support the version 1 of the notification API, but it's using WebSockets and everything, so you get real-time notification. I haven't implemented the version 2 yet, but that will be on the roadmap. So I'm doing something a little bit more complex here. So I can subscribe to operations. So this is, building your WebSocket in the background and saying, when operations come through, can you react? I only want to react to create. I don't care about update because I want to launch basically my workflow only based on the create. So if the operation comes in, I then want to do something. I only want to subscribe for an hour, so you can set whatever duration makes sense to you. And now because I'm not giving a device in there, you can I'm currently subscribing to all operations. Now I want to filter what operations I want to listen to. So I can just use grep because I'm in Linux, grep's great. You can also do your own filtering. I support some rudimentary filter parameters, but if you're unfamiliar with it, just use the tools that you know because everything's pipe friendly. The only kind of trick you do have to use some kind of extra options sometimes, otherwise things don't get flushed properly. But and that's where I can help out with insight into that. So I'm subscribing to each operation. When an operation comes through, the very first thing I do is update the operation to executing. Afterwards, I wait 750 milliseconds. I'm using 10 workers so that if I get a batch of operations at the same time, each operation doesn't need to wait very long before it gets set to executing. It gets sent straight away. Then it passes on to the device update. What this does is actually using a template, it sets the software list on the inventory manage object or the device manage object to the software list contained in the operation. So you can also, in your templating, use what you got inputted and to generate your complex commands. So you can have on-the-fly data and dynamic data being set. Probably sounds a bit like a mouthful at the moment. But I just wanted to get a little bit of idea of how all that kind of magic works. But all of the details are in the concepts page on the online documentation, and I can point to that later. So after we've updated the manage object, then I need to set I need to set now the operation to either failed or successful. So because I've lost my operation here in terms of in the pipeline, I need to fetch it again. So I'm just doing an operation list. That is pipe aware. So they'll go, I see you got an inventory as my input, and then says it's smart enough to say, okay, I know in what field your device ID is, and it gets the operations, and then it updates them based on a template again, because I want to make it dynamic. You'll actually set the operation either to failed or successful based on a probability. So because I'm just going to start that again, and let's say we have, if my numlock works, I want to fail maybe 50% of the time. If I go into my device, now I don't have any software installed, okay? So let's install something. Let's go Vim, why not? In the background, it's not installing anything. It's just mimicking it. So apply. You see it's already set to executing. Set to failed, okay. Let's, I think in the control, we can actually see the error reason. Package was not found in Debian repository. Okay, let's try again. But you'll see it actually updated. That's only because I'm just doing a dumb update kind of thing. But if I change my listener to, I think, always work, I want to pass always. If I do it again and say, okay, play HTOP, and again, so it kind of feels, I don't actually know there's no real agent running in the background here, because my operation's been executing and I added a nice delay so it's not instant, because if it's instant, it doesn't feel real. It's added it to my inventory manage object. Fantastic. And I can actually even remove it as well. And it feels all real. And again, with 4 lines of code or 5 lines. So you can really adapt it to any calls, and you can kind of combine them, chain them however you want, whatever makes sense to you. So this is where I segue into the next process. So let's imagine that I have some kind of build pipeline that I'm building a new agent version. And this agent version or package needs to be deployed on each of the devices in an environment. It could be production or quality, and you have some kind of stage process. But let's just stick with, we have one kind of install, like one Commonality environment. So from that, when I have a new release, so everything's tested, I'm going to assume it's run through all the tests have passed, check. But I want to now upload it to Commonality and deploy it. But now deploying to 100 devices doesn't make sense because that's my whole fleet. What happens if I have a faulty version that somehow slipped through QA and makes out into devices and it starts to fail? So I want to protect myself. So one way of doing this would be having like a canary group. So you have like 10 devices, so 10% or 5% of your fleet marked with specific, hey, I'm a canary group. And then you mark them for deployments with this latest version. If that version goes okay, then let's proceed with rolling it out to all devices. So I've actually prepared a GitHub action to do this. So maybe just first, to show what the steps are, I'll just move into the GitHub action. So for example, here we have a list of all the steps it's doing. So it's not only doing software deployment, like the Commonality software artifact deployment. It's also doing like microservices, the web hosted web applications. So I'm installing like a web app. I have optional a microservice that I can deploy. This is all using the Commonality CLI tools, just in one portable binary. I'm deploying a configuration. I'm adding the software to the repository. I'm installing the new version to the Canary group. If everything goes right, I'll install the new version of that same software that I uploaded to the main group, the remaining devices. So I'm just going to simulate how everything looks. So if I'm going to start my real-time simulator again, like real-time software listener, and give it a 50% chance of being successful. And I'm going to use, so those who don't know, if you use GitHub Runner actions, GH is a great command to use. You can actually trigger all of the GitHub API calls via GH. So in the background, this is what I've done. All right, jumping. So it's triggered another build. This would normally be automatic that you have like on a tag or something like this, but I'm just doing this for simulating purposes. So now how I'm deploying this, so I can see each of my steps, the output, and it has like the objects which are created. It's installing the new version already to Canary Group. So it's doing this via a bulk operation. So it's listed these 10 devices and said, hey, in 5 seconds time or whatever, because you can schedule a bulk operation to trigger in advance and saying, okay, in 5 seconds time or 2 hours, install this new software version to the Canary Group. So shortly we should see a little bit of, oh, it's already done. So I probably need to reload. Something happened with the real time and the UI. So we've seen that this deployment has failed. So 4 was successful, 6 had failed. So you can kind of, and it hasn't gone further because it said, okay, if your Canary Group fails, don't continue because you need to investigate this because it could be something wrong with the environment. Oh, with the artifact that you deploy. Now that in itself, I mean, that's good, but I mean, that doesn't help me too much. I mean, great, it failed, but why did it fail? So investigating this for 10 devices, that's not much, but let's think 200,000 devices. So let's see what output I have there. So inside my error handling, I have analyzing failure reasons. From the failed, so it says the bulk operation success rate is too low to continue. It expected, I guess I've got the wrong set there, success rate to be above something, continue when it's better than that. But I mean, here I'm using the tools to then get a unique list of the failure reasons across all of the deployed devices to see what kind of errors do I have. Is it all the same one? And here I'm just generating random errors, which says fail to download the package, no space left on the device, and whatever. So I can see automatically it's helpful information that I can actually react to rather than just saying it doesn't work. So to enable this, and it'll provide, this is all in a public repo already, so you can see the GitHub action and everything. You can actually see here, like in the install software script, that you have analyzing failure results. How it looks is, so we get the list of operations relating to a bulk operation. I only want the failed. I want to include all of them. So that will say Commossi will do its own iteration over all of the own pagination. So you don't have to worry about that, which is great and handy. So you're not limited to the 2000 devices. Say, give me all of them, whatever that is. I only want the failure reason because I want to actually use some Linux commands, sort and unique, to do my grouping for me. So I can say for those commands to work, because they're Linux commands, I just want to output it as CSV because that is just doing a line delimited output. And then you can do some nice text parsing to get your counts, which is really super useful. And just doing these kind of summaries is really, really useful when you're doing diagnosing really difficult bugs. I've used that many, many times and found things 100 times quicker than if I was just, had to manually do requests and kind of fishing for data. You can really do really powerful stuff here. It can take a while to get, a feeling how to put everything together, but that's the idea. So let's just test again. And for this, I need to check what my error rate was. So this is my template that I'm using to randomly set the operation to fail to successful. So this status, I'm using an if else. So this is supported by JSONet. So I'm doing a random integer between 0 and 100. If that is greater than or equal to my threshold, then set it to successful. Okay, that shows me if I want them all to be successful, I set it to 0. So I guess it's kind of like an error, right? So I don't want any errors, and I'm just going to trigger that again. And so you can see that how it looks on the UI side is that everything. So we should now see that if the canary deployment goes well, that should then do the follow-up deployment because we validated that everything works properly there. So we're happy to go to the next one. In reality, you'd probably have a more longer testing phase in there that you'd maybe do some sanity checks, maybe from spot checks from I don't know, a few different devices. But you can easily integrate that in by just running whatever commands you want in place there. So you can chain them however you want. And when I say chain, you don't have to really physically chain them in the pipeline. You can also do in different function calls however you want. So now we can see that I've labeled everything nicely too, so it's clear it's a CI/CD process. Um, and I think I even put a comment. This was deployed from the CI/CD runner with the run ID 37 or run number, I think. And you see it's now going on to the bigger group of, I think, 90 devices because 100 minus 10. And I can even get the running total here from the Commodity features. I did all of this last night. So it's really not that difficult. Once you have the full kind of an overview of the concepts and understand them, then it actually becomes quite easy. And what I'm looking to do is actually to organize regular calls where it's kind of like a user group just for use cases. How do I solve this, for example? Now that probably leads on to another good question. So yes, I'm just reading in the chat about the documentation. So yes, all of the documentation is available from the online docs and in the command line. So this was actually some of the feature requests, I think, from Corbinian. He's been one of my good testers there. So for example, if I go, I'm trying to create a device. I've got this far, and I'm like, and now what? All of them support an examples. And I'll give you the examples can vary. So once I see kind of like more usage patterns, I can then add it in. Um, but the idea is to have like interactive help there as well. Or if I want to do like list examples, and that spits out the examples. If you want to see the full help, because obviously the full help is a little bit overpowering, the examples are also there. But the examples just to really highlight, because like me, I don't really care about the docs per se. I want to see, just give me an example and then I'll know how to do it. And you can see all of the flags which are supported both on the device and the global flags. And you can see with the global ones, there's a lot of like use cases here to force, to prompt. You can do some cool stuff with flatten, select, so you can do some really cool like JQ stuff. But you can also pipe to JQ. So under the hood in terms of API requests. So it's predominantly HTTPS or HTTP calls. There's currently no MQTT calls. It has been posed to maybe do that, and I think I did some initial research into that and have maybe a Go MQTT client somewhere, but not yet. I think I would see that as another project, and I would probably see if I could utilize because I generate 90% of the code here using a code generator. Um, so it's quite fast to add a new command most of the time. So I'd be but it would be a different, I think, client for the MQTT stuff. But in addition with the HTTP, it does with the exception, does do WebSockets for the real-time communication aspect of it. So you can listen to stuff and be a bit more kind of have a nicer look and feel to it. So I said before that the help's available online and in the console. So online, so this is the page. I've tried to do some real ASCII cinema examples, so you can have a bit more real look and feel of everything. So if you're looking for the exact API calls, you can go to the API section. And you can sort of your alarms create, and then you'll see everything here is kind of auto-generated docs from the commands, and it just outputs it there. So you can kind of do a little bit more better look and feel without even installing it. You may see here, this is the PowerShell variant, let's say. The PSC8Y is a pure wrapper over the Go binary. So it's not like a different implementation. It's just really dumb wrapper over it. I would really recommend just using the native Go, because you can do that in PowerShell still. And I have a few examples how to do that. Because at some stage I might get rid of the PowerShell, because I'm most people don't like PowerShell. I was a fan before, so I know it quite well. However, I think not much interest is there from it. And you can still use it inside PowerShell if you really want, but you can use the native calls in PowerShell. That's fine. So on the online docs, where you can go into more, so obviously there's an installation section. So there's also shell, Docker, PowerShell. 9 times out of 10, shell, Docker, only if you really need to, adds a bit of overhead, I guess. But what is really, so after you install it, I would really recommend reading the concepts. So there's a whole heap of features that I have not even touched on today. Each of the core concepts are listed here. Why usually, like the use case, why I implemented that, because it's always come from like a concrete use case I've had either with a customer or just me using the platform. They're all detailed here. So, like activity log. So after the fact, if I say, something exploded because I know I was doing something bad that I shouldn't have, I can actually see what calls did I do. I know date from in the last 10 minutes. Let's pipe that to JQ, and you can see, okay, this is the REST call I did. This is the response time it took from the server, a self-link to the objects, and you can kind of see what happened when, a little bit to trace down complex stuff. So those things come in super handy, and maybe some, if you are a little bit more familiar, one of the newer features is having a caching option, which is really cool. If you go into using in scripts and later on, you can do a really cool deduplication thing. If you have, if you want to, like, I know, preload data into a tenant and you want to pick up where you left off without duplicating the requests, very recommend doing that one. So there's a lot of like a context, and it's written from a user point of view, that it's saying a bit of a introduction why, how to configure it, and usually a few examples, how to use it for individual stuff, etc. So there's quite a lot of topics here. I would really recommend using that because you can really get the most out of the platform. And because I mean, this tool is only possible because Comlossi has such a strong REST API, and they only ever add stuff to the REST API or add a new API call. So you're usually pretty safe not breaking anything, which is great. And so, and for example, all of my commands, you can add additional query parameters if I don't support it yet. So you can really, it's really flexible and adaptable to the future. And as you may have seen, for example, on the command line stuff, I would recommend Zshill if you're in Linux. You get command completion for everything. So example, you'll see all of like the sub commands. If I want to go maybe devices, operations, create, device. Okay, I want device. What device do I want? Tab. You go, hey, do you want to show 100 lines? Okay, maybe not, because that's a bit too much. Tab. And it gives me the list of devices. And I can actually reference devices by name and all this kind of wonderful stuff. So it means that you're, and because I'm trying to create something there, that's why it failed. So you can do some wonderful stuff there, which you can write the code So it's actually tenant agnostic. So it means you can run the same script without searching for IDs, because 90% of the time, your device names are unique. Unless if you have really special use cases, but then you can write your own kind of script to resolve to the specific devices and then work with IDs. So all of these concepts, for example, that is reference by name, are detailed here, that accessing, why, etc. And it's deployed to a lot of like applications and microservices and everything. Yeah, so it's quite powerful. I'm always improving it. I am pretty good. The API doesn't break too much. I don't make breaking change, so I try to adopt the same kind of concept, that don't break anything. Just try to add something to it. And if I deprecate anything, I'll mark it as deprecated and wait 2 versions or whatever. It'll be properly communicated. So are there any? Yeah. So I'm reading questions. In each session, can you use the same encryption, or is it a per session kind of thing? I think by default it's actually a per. You can actually configure it how you want. By default, it will be for all sessions, but you can actually activate it for different sessions. So, for example, I've activated it for this demo session, so I can show you how my file looks like, because the password is then encrypted. And it uses a salt, which actually is stored on your file system as well. And it combined with that, it then saves your password. If something happens with that encrypted like salt there, it's okay, because it will just say your password's wrong. Can you please re-enter your password? So if something happens to it, it's not too bad. But you can actually enable it per session, use the same one. So I think encryption here, I've enabled it, and I've actually disabled caching the passphrase. So that means for every time I switch session, I need to enter it in again. But if that cache passphrase is set to true, I only need to enter it in once, because it stores in the environment variables a copy of your passphrase, and we'll use that to decrypt your session. But maybe just to explain how that's actually working. So in the background, when you set your session, so you can actually do, I have, I think 50 sessions that I have defined, and you can do like searching and everything. So I'm just hiding sensitive information at the moment. So you can actually do this quite nicely, and yeah, you can control a lot of things just per session or a global session, which is kind of useful. Yeah, and so when you set the session, it will actually create environment variables. I won't do that because I actually see, I can show you one maybe. It will set some environment variables, and then when the command line runs again, because every time you run the command, it reads and it will check if there's environment variables, read them, and if they're not there, read from the file. But reading from the file is very slow, so usually it tries to get it from the cached environment variables. But in addition, by writing these environment variables, this is actually super useful for being tool friendly with like the C8Y CLI, the official Node.js variant for an NPM, because we're setting all the environment variables that that tool needs. So you can kind of let the Go C8Y CLI do the session management, and you can still use your existing tooling as if. You can even use curl and reference special environment variables that I created just for this very use case. Going inventory, managed objects. And I didn't need to worry about anything about authentication. And because I set an environment variable called C8Y header. And so you can use it with other tooling. So it's really, really convenient. And if you say, you know what, I don't like using it for whatever reason, okay, fair enough. You can use your own curl and just reuse the environment variables. Because one thing that the set session also does it handles two-factor authentication, tokens. So if you have the internal OAuth 2 enabled in the Cumulosity, which I would really highly recommend, and I think that will become standard. So it will use also token-based authentication and all this kind of stuff. Everything's available. And it's quite convenient. And then you don't need to do your own TFA handler in your Python CLI if you're writing that or whatever. And yeah, so and in that session file, it's just a JSON file, so you can actually edit it however you want. But obviously for like a CI/CD environment, you usually don't want to do this. So you usually have like some environment variables that you set. So for example, here in the secrets, like from the GitHub secrets, I just set the global environment variables. Then I don't need to worry about anything with the session, because the Cumulosity tool will go, okay, I see that you've already defined these variables. They work, all good. Yeah. So
Ruben,
yes, exactly. So I if there's additional questions, but at least that's from my side. Obviously, I could go on for this forever, but
thank you, Ruben. Yeah, there's actually one question that was asked earlier on.
okay, yeah.
Have you considered accepting DTDL templates so that the customer can share a proper device representation and telemetry structures?
Yeah, I'm definitely open. I have kind of in my template generator, I have kind of earmarked that maybe with templates you could inject some kind of support different templating languages, maybe. So currently JSON is the only one. But for example, how that could work is that if you had um, a DSL interpreter or whatever, that just converts from there to a JSON template or to JSON, you could just use that in the pipeline then. So for example, I have also so imagine that here, I don't know, you have data queue. That this replace the C8Y template execute, that could be your DSL interpreter that takes this customer specific file and then it exports it as JSON in the pipeline, and then the Cumulosity can create it from there. I mean, it's quite flexible, and that's the advantage by just interpreting standard input, that you can do anything with it. So if you do the data shaping before Cumulosity, like before the CLI tool, then you can really do anything with it.